SpaceX, at the forefront of revolutionizing space exploration as Ship 25, prepares for a crucial static fire test. Also, in this video we will analyze the signs that suggest a potential Starship launch in the coming weeks, but that's not all. NASA astronauts are up for a thrilling spacewalk outside the International Space Station. How will Ship 25 do in its static fire test? And are we on the edge of witnessing a historic Starship launch? Let's delve into the exciting progress at Starbase as water tanks arrive on the site. They are a crucial component in the deluge system, which helps protect the launch mount from the intense heat generated during launch. Next, we witness the chopsticks, a pair of towering structures rising against the backdrop of the Starbase. These structures play a vital role in the stacking and integration of the Starship, ensuring stability and precision during the assembly process. If we get a closer look at the chopsticks, strong cables and mechanisms involved in the assembly and transportation of these colossal spacecraft. Moving towards the orbital launch mount and launch tower. This towering structure stands tall, ready to support the massive Starship during launch. The OLM serves as the interface between the launch mount and the Starship, facilitating the fueling and integration processes. At Orbital Launch Farm, there is a cluster of cylindrical tanks situated in a neatly organized formation. These tanks store the propellants required for the Starship's launch to space. The tank farm is a vital part of the launch infrastructure, ensuring a steady and reliable supply of propellants for successful missions. Up next, the dedicated crews are preparing tank interconnection. These skilled individuals work diligently, connecting pipelines and ensuring the seamless flow of propellants between the tanks and the Starship. Their expertise and attention to detail are crucial in maintaining the fueling process. There is Ship 25 positioned on suborbital Pad B. This specific Starship, with its sleek design and distinctive features, is undergoing preparations for an upcoming static fire test. The anticipation builds as we eagerly await the test dates and the significant milestone it represents in the development of these spacecraft. We also witness the lifting rig being lifted into position. This heavy-duty apparatus, with its sturdy frame and powerful hoisting capabilities, is an essential tool in handling and positioning various components of the launch system. Also, the water tank is being lifted off the ground and is carefully placed into position. Now, moving towards the Massey's site, our attention is drawn to Nose Cone 31, which is prominently displayed at the test range. This component, with its sleek and aerodynamic shape, represents the forefront of design and aerodynamic optimization in the Starship program. Its presence at the test range indicates ongoing testing and refinement of this critical part. Adjacent to Nose Cone 31 stands the S-26-1 prototype. This prototype, with its unique features and configurations, serves as a testbed for various systems and technologies. It is through rigorous testing and evaluation of prototypes like the S-26, one that SpaceX can fine-tune their designs and ensure optimal performance. There's also update about Massey's liquid nitrogen tanks, an essential element in the testing process. These tanks store and provide the cryogenic fuel required for testing purposes, showcasing the diverse range of propellants and fuels used in SpaceX's operations. Now, returning to lifting rig, we witness it being connected once again, signaling another critical operation about to take place. The repeated use of the lifting rig highlights its versatility and importance in handling and transporting heavy and delicate components. Up next, we witness a ship shuffle. This activity involves moving various starships within the build site, possibly to facilitate different stages of construction or testing. The coordinated efforts of the ground crew ensure smooth and efficient repositioning of these massive spacecraft. Also, the deluge pipe is being lifted. This component, part of the deluge system, is carefully taken into position to provide the necessary water spray for launch pad protection and safety. We also have update of High Bay, an impressive structure that stands alongside the bustling build site. This facility plays a pivotal role in housing and preparing the starships for various tests and operations. Transitioning to the suborbital launch site, we witness the preparations and infrastructure in place for suborbital launches. This site plays a crucial role in testing and validating different aspects of the Starship's performance, including vertical takeoff and landing capabilities. We also witness the delivery of liquid nitrogen to support ongoing operations. Moving back again to Ship 25, we get to see the flaps extended, indicating that this particular Starship is undergoing preparations for a test or launch. The deployment of the flaps plays a crucial role in controlling the vehicle's aerodynamics during different phases of flight, showcasing the dynamic capabilities of the Starship. Also, we witness a new section of the Mega Bay being lifted into position. That was all regarding latest updates from the Starbase. Up next, we will do analysis on why we think launch of Starship is near, as the teams at SpaceX have been diligently preparing for the next launch of Starship since its last attempt nearly 2 months ago. After returning to the launch pad, their immediate focus was on clearing debris and assessing the damage caused during the previous launch. Now, after weeks of dedicated work, Stage 0 and all the key infrastructure at the launch pad are nearing completion. However, the readiness of Stage 0 is not the sole determining factor for Starship's next launch. The rocket itself has also been progressing rapidly, with Elon Musk providing new estimates suggesting that another full integrated test flight could take place in just 2 months' time. This ambitious progress is indicative of SpaceX's unwavering determination to successfully launch Starship into orbit. One crucial aspect that has grasped attention is the water-cooled steel plate, a design element integral to the launch system. Recent testing has provided valuable insights into the effectiveness of this plate, bolstering SpaceX's confidence as they approach the completion of the full system under the Orbital launch mount. Looking ahead, there is a possibility that we may witness Starship lift off again before the end of summer. The first test flight, on April 20th, aimed to propel Starship's upper stage spacecraft most of the way around Earth. While the mission achieved significant milestones, it also encountered several serious problems, resulting in SpaceX issuing a self-destruct command shortly after liftoff. Since then, both SpaceX and Elon Musk have provided updates and timelines for the next launch. However, estimating the launch date proved challenging due to various factors, not just the readiness of the launch vehicle. The pad structures also required thorough evaluation to ensure their functionality. Elon Musk recently indicated that the next Starship launch could occur within 6 to 8 weeks. While Musk's ambitious timelines have occasionally faced delays, the relatively short estimate remains promising. It suggests that the launch may be just a few months away, reinforcing the progress made by SpaceX. While the pad damage revealed after the first launch was concerning, Musk expressed relief, stating that the damage was relatively minor and could be swiftly repaired. He clarified that the estimated launch timeframe specifically referred to the pad's readiness, excluding the rocket and other external factors. Nonetheless, the pad still requires additional repairs and upgrades before the next launch can take place. In addition to the technical challenges, SpaceX may also encounter regulatory hurdles. A union of environmental groups is currently suing the U.S. Federal Aviation Administration, which issued Starship's launch license. Criticism has been directed at the FAA for allegedly neglecting to adequately assess the potential ecological and community impacts that the colossal Starship vehicle could pose to the South Texas ecosystem and the surrounding human communities near Starbase. Pre-launch testing holds significant importance for SpaceX's next launch of the Starship. In a few weeks, Booster 9 is scheduled to undergo a full static fire test. This test will not only evaluate the booster itself, but also the new water-cooled steel plate that has been implemented. The outcome of this test will have a direct impact on the launch date. If the steel plate fails to function as intended, it could result in significant delays. However, if the test proves successful, it will keep the launch on track. Moreover, the test results could potentially support SpaceX in their lawsuit against the Federal Aviation Administration. SpaceX is required to inform the FAA about any modifications made to address the issues encountered during the first flight. A successful Booster 9 static fire, coupled with the effectiveness of the steel plate, would serve as compelling evidence in their case. The initial launch of Starship did not go according to plan, experiencing several setbacks. The problems included damage to Stage 0, multiple engine failures, communication loss, and delays with the autonomous flight termination system, all of which hindered the rocket's stage separation. Elon Musk acknowledged the near success of stage separation in the previous launch, expressing that maintaining thrust vector control and throttling up as intended would have achieved staging. The goal for the upcoming flight is to successfully reach staging and ultimately achieve orbit. The next flight will follow a similar profile to the previous one, focusing primarily on gathering information without a specific payload. The main objective is to learn as much as possible from the test. Despite the relatively short duration between the first and second flights, there have been numerous improvements. The initial test flight involved Booster 7 and Ship 24. Elon Musk eagerly expressed his desire to launch the rocket, regardless of the outcome, due to the significant enhancements made between Booster 7 and Booster 9. Extensive improvements have been made, including the transition from hydraulic to electric thrust vector control and a complete redesign of the heat shield structure on the base of Booster 9. Unlike Booster 7, which had a retrofitted heat shield system between the engines, Booster 9's heat shield has been entirely revamped. The significance of this redesign lies in the risk associated with 33 engines. If one engine malfunctions, it poses a considerable threat to the entire system. Elon Musk analogized this scenario, comparing it to having a box of really big grenades. If one goes off, you don't want the others to go off as well. The goal is to successfully launch Booster 9 and move forward with the improved design. Elon emphasized the importance of maintaining thrust vector control for the next flight. Isolating thrust vector control with Booster 9 is significantly easier due to the utilization of electric motors to steer the engines instead of hydraulic actuators. In the previous design, hydraulic actuators shared a common manifold, posing the risk of losing multiple engines if hydraulic pressure is lost. The use of electrically actuated engines in Booster 9 ensures greater isolation and minimizes the possibility of a single event failure, as long as power and communication are maintained. Elon Musk, CEO of SpaceX, expressed his belief in the Starship's potential to reach orbit, stating an 80% probability of achieving this milestone within the year and a near certain 100% chance within the next 12 months. In anticipation of the upcoming flight, Musk shared some insights into the improvements and expectations for the next launch. One of the key objectives for the next flight is to start the engines and get off the pad faster. Musk highlighted that the time taken from engine start to moving for the previous launch was around 5 seconds, which is quite long and puts significant stress on the launch pad. The aim is to cut this time in half, reducing the strain on the pad and improving overall efficiency. The successful launch of the previous vehicle, despite encountering challenges, was a positive step forward. SpaceX has made substantial improvements in Super Heavy Booster 9 and beyond, and now the focus is on flying this vehicle and moving on to an even more advanced booster. Booster 9 has undergone numerous changes, making it a standout among the updates. The only contenders for significant changes are the launch pad itself and the new water-cooled steel plate. During the first launch, the pad relied on a special heat-resistant concrete for protection. Although it was believed to withstand at least one launch, SpaceX has decided to upgrade to an industrial steel plate with extensive plumbing underneath the entire launch mount. A recent video shared by SpaceX showcased a test of the system with a Raptor engine. While the test involved only a single Raptor engine, instead of the full complement of 33, it demonstrated the close proximity of the steel plate, approximately 7 meters away from the engine. This distance is much closer than the space between the top of the orbital launch mount and the ground, where the full plate will be installed. The successful test of the water-cooled steel plate system provided SpaceX with the confidence to proceed. It is crucial for the system to perform flawlessly and endure multiple launches to realize the vision of a rapidly reusable Starship. Furthermore, the launch pad and supporting structures also need to withstand the demands of frequent launches. Repairing and fixing the water-cooled steel plate after just 1 or 2 launches would defeat the purpose of its implementation. With the progress being made at Boca Chica, where SpaceX is actively working on these improvements, the company remains optimistic about the possibility of a launch within the next 2 months. While this goal is ambitious, it is supported by the ongoing work on Stage 0 and the new Starship prototype. Up next, 2 NASA astronauts spacewalk outside Space Station on June 15th. In an exciting development, 2 NASA astronauts are gearing up for their second spacewalk outside the International Space Station on Thursday, June 15th. Woody Hoburg and Stephen Bowen have been assigned the task of installing a cutting-edge rollout solar array on the exterior of the International Space Station. The spacewalk is scheduled to commence at 8:55 a.m., and the astronauts are expected to spend approximately 6 hours completing this crucial installation. It is worth noting that this spacewalk comes just days after Hoberg and Bowen successfully completed their previous mission on June 9th. During that EVA, they expertly installed one of the solar arrays, known as IROSAs, in an operation that lasted 6 hours. This marked Hoberg's inaugural spacewalk, while Bowen's participation added to his extensive experience, bringing his total EVA time to nearly 60.5 hours across 4 career spaceflights. Their combined expertise makes them a formidable team for this critical task. The installation of the IROSAs is a significant milestone for the International Space Station, as these cutting-edge arrays will enhance its energy production system. Rather than replacing the existing infrastructure, the IROSAs will work in tandem with the station's current setup. NASA officials have estimated that the addition of these arrays will increase the outpost's electricity generation capacity by approximately 30%. This boost in energy production is a crucial step in advancing the capabilities of the ISS and supporting future scientific endeavors. While Hoberg and Bowen prepare for their spacewalk, 2 Russian cosmonauts are also gearing up for their own extravehicular activity, scheduled for June 22nd. Commander Sergei Prokopyev, alongside Dmitry Petlin, will venture outside the Russian segment of the ISS to perform various tasks. These include the replacement of communications and science hardware, as well as capturing detailed photographs of the Zvezda service module's condition. This upcoming spacewalk highlights the collaborative efforts of international space agencies in maintaining and upgrading the International Space Station. The significance of these spacewalks cannot be understated. They serve as a testament to the incredible feats of human ingenuity and engineering that have made long-duration space missions possible. The astronauts' bravery and expertise, combined with the support of ground control teams, allow humanity to explore the frontiers of space and conduct groundbreaking research. Up next, Pentagon gearing up to launch first experimental navigation satellite in 50 years. In a significant development for the nation's satellite navigation capabilities, the Pentagon is gearing up to launch the Navigation Technology Satellite 3, a pioneering spacecraft. This marks the first experimental navigation satellite to take flight since the launch of NTS-1 and NTS-2 in the 1970s, signaling a major leap in navigation technology. Developed by L3 Harris Technologies, NTS-3 has recently completed rigorous testing at the renowned Benefield Anechoic facility located at Edwards Air Force Base in California. The state-of-the-art facility enabled technicians to thoroughly assess the satellite systems without any interference or accidental disruption of nearby air, automotive, and other global positioning system signals. The deployment of NTS-3 comes as a response to the growing potential threats faced by existing satellite navigation constellations. Resilient approaches are imperative to increase the GPS system and ensure uninterrupted user access, as stated in a press release by the U.S. Space Force. Additionally, this groundbreaking satellite will also test technologies to maintain GPS connections in military conflict zones. Amarachi Egbuzium Chiolkosh, an engineer with the 772nd Test Squadron, highlighted the wide-ranging impact of NTS-3 by stating, "It's probably going to affect so many lives, not just military but commercial alike, and help with all of our GPS systems." The BAF, the largest anechoic testing site worldwide, conducted its first satellite test in decades with the evaluation of NTS-3. It is a quiet enough chamber that protects aircraft and other GPS users outside of the facility, explained NTS-3 program manager Ariel Beersgreen. "We needed to have a shielded area large enough to keep the energy of the testing inside the facility. Across the board, the BAF fit the bill in a way no other facility in the United States really could." NTS-3 Chief Engineer Thomas Roberts emphasized the significance of the BAF's role in the project, stating, "Whether it be airline schedules, takeoffs and landings at airports, or military operations, NTS-3 is taking this a step further because we are doing a demonstration of advanced signals and signal flexibility. Our ability to get that job done is dependent on the success of this testing facility. With preparations on track, NTS-3 is set to launch later this year. However, before that, it will undergo crucial thermal vacuum tests at Kirtland Air Force Base in New Mexico. These tests will simulate the harsh conditions of space to ensure the satellite's performance meets expectations once deployed in orbit. NTS-3 is scheduled to operate in a near geosynchronous orbit for approximately 1 year, assuming all goes according to plan. According to the press release, the recent successful testing at the BAF was made possible through a collaborative effort between the US Air Force Research Lab, the Space Force, and NASA's Jet Propulsion Laboratory. Each entity played a critical role in this historic testing phase of the NTS-3 satellite. As the launch of NTS-3 draws near, anticipation mounts for the enhanced navigation capabilities it promises to deliver. This technological advancement will not only benefit the military, but also have a far-reaching impact on commercial sectors. The successful testing at the BAF and the upcoming trials at Kirtland Air Force Base mark significant milestones in the journey toward a more resilient and efficient GPS system. That was all the space news for today. Will the successful completion of the static fire test bring us closer to the long-awaited next Starship launch? Or are there other challenges that lie ahead? Share your views in the comments section below.